learners. Welcome to Drawing and Design Form 1. My name is Peter Kamwelo. I teach Drawing and Design at the Moi Forces Academy in Nairobi. Today we are going to do basic construction, particularly quadrilaterals. In the last lesson we stated a number of quadrilaterals, and we said that a quadrilateral by definition is a plane figure which is bounded by 4 straight sides, and the examples we give as square. We give it as also a rectangle, rhombus, trapezium, parallelogram, and kites. We are going to learn to construct each one of these quadrilaterals given specific conditions. We expect that by the end of this lesson that the learner should be able to construct a square given a side, construct a rectangle given 2 sides, all given a diagonal and 1 side, excuse me. Construct also a rhombus given 1 side and 1 angle, and also construct a parallelogram and a kite. Now on to the first construction of a square. Side 70. As we said earlier, all measurements are in millimeters, and therefore we don't write the units. There's no need. All dimensions are in millimeter. When we require to use another one, we specify, but otherwise all dimensions are in millimeter. Now, to start with, we have our length, and we have said that the length AB is 70 centimeters. Now, given that length of AB, by now we have mastered erecting a perpendicular from any of the vertices or points on a line, and therefore we make our arcs, and we erect a perpendicular line from a point of starting, in this case vertex at A. So join the point of intersection between the arcs and the point A, and we have a line at 90 degrees to the original line AB, meeting the line AB at A. Now get the length of AB. To get the point of intersection at the point C. Proceed to show, to draw the lines connecting the 4 points to complete the square. Now, for the purposes of clarity, we outline the complete square ABC. CD is the required square. Now we can do the same also given the square and the length of two diagonals, so that let the diagonals intersect at 90 degrees. So the diagonals of the square are each 70. This is the diagonal. And this one is X W Y. Bisections will give us the other diagonal. So the diagonals of a square are equal and they meet at 90 degrees. So it's possible to draw a square when you are given the length of the diagonal, the two diagonals. So again, at that point, if we get the point of the bisection and point Y or W, we can be able to know where the point Z and X are. WX, and this is that. So the subsequent figure is a square. This resultant figure there is a square, where X, W, X, Y, and Z is the required square. Given, you are saying here, square this is square. Given the diagonal, so this is here, then this diagonal is 70. And when the two diagonals are equal and they meet, they intersect at 90 degrees. Okay, the next quadrilateral, learners, is the rectangle. Rectangle, in this case, we've been given sides 8 millimeters by 50. So how do we construct a rectangle? Rectangle given sides. Given sides So construct the base 8 millimeters. Millimeters. Our length AB is that length, so we look for C and D by construction of a line perpendicular to AB meeting the line AB at A. So again, we do the usual construction for perpendicular line at point A. So mark point B equal to 50. This is point D equal to 50. If you make an arc here equal to 50, and also from this point B there, mark that point to get C, then the vertices found are the vertices of the required rectangle, and we proceed to outline that figure to complete the required rectangle. So ABCD is the required rectangle. With the conditions as given the two sides, 80 by 50 millimeters. The rectangle can also be drawn using the skill we learned in the last lesson of constructing a right angle triangle given the hypotenuse. So the second method of a rectangle is when you are given the diagonal, rectangle given the diagonal and one side. So let's start this one so that we know. If this one is our A method, we are doing B rectangle given diagonal. Diagonal on one side. So our diagonal, let our diagonal be once again 90. Let's have 93 millimeters. So 93 millimeters. We bisect the diagonal. Proceed to draw an arc whose radius is equal to that point of the bisecting with x and also w equal to that. Draw an arc and let it go beyond the semicircle line so that approximately 3/4. Mark the side so that we have that point and that point on either side of the diagonal, and proceed to join them so that we can be able to locate or to draw the required rectangle. So this is the required rectangle. We can, for the purposes of having the alphabet, we line W, X, Y, and Z. When you are now W, Y is the diagonal, the original diagonal, whose length is 93, and this one was 43, and this one, the original diagonal here, form the rectangle. We have said that diagonal represented by vertex Y and W and Y is 93 for the purposes of this construction. Learners are encouraged to get the length of side ZY, and also WX, and test whether the angles performed are each one of them 90 degrees. So the next construction is construction of a robust. A robust is that quadrilateral whose four sides are equal and the opposite sides are parallel. So, and our conditions for the robust in this construction is, can we be able to construct a robust when we are given one side and one side? So, robust So, as we said, the next construction is for a robust. Robust, and in this case, we've been given the base as 60 and one angle as 60 degrees. learners, with the skills that we learned in the last few lessons, this one should be quite easy to us. Given again, with one this angle as 60 degrees. So construct the arc there, and when you make a single stripe using the same radius, the angle formed in there is 60 degrees. So draw the line connecting vertex A with the arc intersection clockwise, and you have two sides. If you mark on the new line a length equal to AB, that way, and then got two intersecting arcs from B and then you point. So you are able to get this is point C and this is point D. And those are the vertices of the required robust. Continue to complete the robust. And the outline, the entire figure, so that you have the complete robust A, B, and C, and A, B, C, and D. And as you can see, the two opposite sides are parallel, so that this is parallel to that, and also the line AB is parallel to the line BC. The sides are each equal to 60 millimeters. Now, robust can also be constructed when you have been told that the conditions are that you are given one diagonal, length of one diagonal, and the length of one side. You are going to note that when you look at this robust, it has one longer diagonal and another shorter diagonal, joining D and B, and one joining at A and C. The two diagonals bisect each other, and they do so at 90 degrees. So the second method is when you are given one of the diagonals, you are given one of the diagonals and one side. Say that the diagonal given to us is 70 millimeters. W, Y. So the first thing that you do is bisect that diagonal, because as we said, the diagonals of the robust bisect each other. So we bisect the diagonal of the robust. And then from one edge of the line which is at W or Y, proceed to mark the length of that is given of 55 millimeters to complete the required robust. So then this is the original diagonal, which we say is 70, and the side, this is x, only xy, and the z. The sides of the robbers are all equal, therefore xy. Okay, let's put it above here for clear visibility. That one is, we say, again, given that the diagonal, one of the diagonals is 70 and the length is 55. So this is it, and this line is parallel to this, and this one is also parallel to that. And the two diagonals are meeting at 90 degrees, and this is the robust given one side and the diagonal. One side and one. So one side, you can say even side because all sides in a robust are equal. Now, the next construction of the quadrilaterals is the rhombus, also called the parallelogram. The parallelogram, this one is a quadrilateral which with two opposite sides being parallel. Now we have been given, in this case, two sides, 80 and 45. 80 millimeters and 45 millimeters, and the included angle as go to parallelogram. Parallelogram. included angle of 75 degrees. Now, an included angle is the angle at the point of intersection between the two sides that are given. So, if our line again is eight millimeters, and this one is A and a B. We proceed as follows. First, construct an angle of 75 degrees. This one, we already have the skill of constructing angles, so we start by 90 degrees. And we know that this arc is equal to that radius. When you join it to the original point A, we are able to draw an angle of 60. So the difference between the angle of 60 and 90 degrees is 30 degrees, and when we bisect it, we get 15 degrees. So that is our measurement for this, so that we have 60 degrees here, and we have 90 degrees, and the bisection of that angle gives us 15 degrees. When we add that one to 60, we are able to get 30 degrees. So when we bisect 30 degrees, then we get 15 degrees, and when we add 15 to 60, we get 75 degrees. So in other words, what we have said is that we have constructed already an angle of 75 degrees. So on this angle of 75 degrees, mark 45 millimeters. 45 millimeters. So this is 45 millimeters, and because of the way we are eliminating the vertices A, B, C, and D, so that one becomes point D. So from A, again, with the distance equal to AB, we can mark an arc from B that way, and then from B with an arc equal to AD, we mark another arc from B to cut that one. So where the two of them intersect, that point is C. Now, if you draw A, B, C, and D, we get the required parallelogram otherwise called a rhombus. So you'll notice that this line is parallel to that, and this line is parallel to that. So and the angle here is 75 degrees. Diagonal and 2 sides. B of that one, well, we are given 2 sides. Eight, and 43 and 1 diagonal. Say that one is, you're given 43 and the 80, and then you're given 70 millimeters. So draw once again the original line at 80 millimeters. This is our A and B. If that is 80 millimeters, we proceed to draw, to mark the shorter diagonal, assuming that this is our 80 millimeters. You mark clearly that one on your ruler, on your set squares, and mark. So this is my 70. If I mark 70 there, and also get 43, which is approximately this right there, and I mark it from B, I can say that that is the shorter diagonal, and already I've got 2 sides there, and 1 diagonal. So the parallelogram will be gotten by getting the same measurements on this side and B. Now starting from C is that point, so that I can get C and also D, and when I join all of them, I have the required parallelogram where this is parallel to that, and this one is parallel to that line. Good, and we have learned that method. So learners, once again we've been able to go through the quadrilaterals. In this lesson we have learned various ways or 2 methods of constructing a rhombus. We have also looked at the construction of a square construction of a rectangle given various conditions. And finally, we've been able to look at the rhombus, also called a parallelogram. In the next lesson, we are going to look at the trapezium, and we are going to look also at the kite. So until next lesson, learners, goodbye.